When you are revising and studying maths and learning maths, it's obviously easier if you can learn one method which works for numerous questions rather than a different method for each question. And in this video, we're going to look at how to integrate sine to the power of nx dx, where n is any odd number whatsoever. So instead of having to learn how to integrate sine cubed x dx and separately having to learn how to integrate sine to the 5x dx, we're going to use this one method which will integrate all of them by exactly the same method. Okay, so let's have a look. So we got the integral of sine to the n x dx, and what we're going to do in every single n is we're going to split it into the integral of sine to the n minus 1 x times sine x, which is sine to the power of n x, and then sine to the n minus 1 x. We are going to use the trigonomic identity cos squared x plus sine squared x equals 1, i.e. sine squared x equals 1 minus cos squared x. We are going to use that and we are going to put it in here so that we're going to have equals the integral of brackets 1 minus cos squared x to the power of n minus 1 over 2 times by sine x dx, and that sine x has just come down from here. Okay, now you might think this is actually more complicated, but in fact it isn't, because we know that as n is an odd number, then we know that n minus 1 is an even number, so we know that n minus 1 over 2 is also an integer. What can we do with this integral? Well, in actual fact, what we do is we use the substitution u equals cos x, so that du equals minus sine x dx, and then when we amend our integral using the substitution, we will get 1 minus u squared to the power of n minus 1 over 2 times by minus du, because we're just replacing sine x dx by minus du, and now we have a relatively simple polynomial to integrate. So let's do this with a specific example, but it works for all of them: sine cubed, sine to the 5, sine to the 7, sine to the 9. So let's just have a look at, say, for example, the integral of sine to the 9, sine to the power of 9x dx. Okay, and we're going to use our formula. We know that by using the 1 minus cos squared and our substitution u equals cos x, it is going to give us the integral of 1 minus u squared to the power of, well, if n is 9, then n minus 1 is 8 over 4 to the 4 du minus all of that. So the answer to the integral of sine to the 9x is minus the integral of 1 minus u squared to the 4 du. Now all we need to do now is just expand 1 minus u squared to the 4, so that will be equal to, it's just a polynomial expansion, so that will be 1 minus 4u squared, add, because this sign just oscillates between minus and negative, 6u to the 4. This again, and this is using Pascal's triangle as well, minus 4u to the 6, add u to the 8 du. So basically that integral equals that, and all we've done there is just use Pascal's triangle, 1, 4, 6, 4 and 1, and then all we've got to do is integrate them. So that equals minus u minus 4u cubed over 3, add 6u to the 5 over 5, minus 4u to the 7 over 7, add u to the 9 over 9, add a constant of integration. And then all we need to do is replace, because we let u equal cos x, we just need to put cos x back into our answer now. And so the answer to the integral of sine to the 9x dx is equal to minus cos x, all we're doing is replacing u by cos x, which is the substitution, minus 4 cos cubed x over 3, add 6 cos to the 5x over 5, minus 4 cos to the 7 x over 7, add cos to the 9x over 9, add a constant of integration. It works for 9, 11, 13, 1001, you name it. Of course, the higher the odd number goes here, the more complicated the polynomial expansion is going to be, but it will still be 1 plus u squared to the power of something, and it will still be a polynomial integration. In the next video, we will do how to solve integrations of sine to the power of nx dx, where n is even.